Okay, so let's do this train problem, this acceleration problem. So what we're told in this problem is the train starts out 5.25 kilometers from the station, and then over the next 3 minutes moves to 3.75 kilometers. And it's doing this at constant speed, at a steady speed for that stretch. So I think a lot of times, or almost all cases, it's really nice to draw a little bit of a visual representation of what's going on. That's kind of what I've done here. I've drawn the station here at x equals 0. I've got the initial position of the train at 5.25 kilometers and a final position at 3.75 kilometers. Right. And so it took 3 minutes to cover that much distance right there. So we've kind of represented that on the diagram as well. So the first part of the problem then, we're asked to calculate what was the speed of the train over this stretch, or at least what was the velocity of the train. So if we want to calculate the velocity is defined as the displacement divided by the elapsed time. Okay? And so the displacement is the final position minus the initial position. So the final position is 3.75 kilometers. The initial position was 5.25 kilometers. Okay, we divide that by the elapsed time, which is 3 minutes. Okay, so 3 minutes. Okay, so we bring this down over here. 3.75 minus 5.25 is negative 1.5 kilometers. And that's divided by 3 minutes. Okay, so we're going to get an unusual unit here for velocity. We're going to get kilometers per minute when we divide this all up here. Now, we really want a kind of a more reasonable unit. So let's get it in terms of kilometers per hour. Okay? Now, remember our unit conversions here. We want to get this in kilometers per hour, so we need to convert minutes to hours. We want to do it in such a way that the units work out. So the only way that's going to work out is if we do some kind of conversion in minutes per hour. So if we do that, the minutes will cancel out and we'll be left with kilometers per hour. And there are 60 minutes in 1 hour. Okay, so we do this little multiplication right here, and when you do that, you get negative 30 kilometers per hour. Okay, so there's our answer, negative 30 kilometers per hour for that first, for the first part. Okay. Now, in the second part of the question, we are asked to find the acceleration of the train, and we're told that it takes 20 seconds for the train to slow to a stop from this speed. Okay? So we're going to need to create some space here, so why don't I go ahead and just erase all this. But we're going to keep this answer here. We'll write that up somewhere here. So, so the velocity was negative 30 kilometers per hour. Okay, so what we're told in this last problem, in the last part of this problem, is the train slows from this speed to a stop in 20 seconds. So in 20 seconds, this train comes to a stop. Okay? So what we need to do now is figure out what the acceleration is. And acceleration is defined as the change in the velocity divided by delta t. Okay? So the change in velocity would be the final velocity. And so this is our final velocity. The train comes to a stop. So the final velocity is 0. Okay? So we have to do final velocity minus initial velocity. The initial velocity was our answer from part A. So that's minus 30 kilometers per hour. Okay? All divided by the time over which the train slows down, and we're told that's 20 seconds. Okay? So here we have minus a minus. That gives us a plus. Okay? So we can take that down over here. 30 divided by 20 is 1.5. But look at these strange units we get here. We have kilometers per hour per second. Okay? Kilometers per hour per second. Okay? That doesn't really make a whole lot of sense. I mean, it's acceptable. I mean, this is the answer in terms of kilometers per hour per second, but we want to have it in a more meaningful unit. So let's convert it to our standard meters per second squared units for acceleration. So to do that, we need to get kilometers to meters and hours to seconds. Okay, so let's first do the kilometer conversion. Okay, we're going to want to convert kilometers to meters, and there are 1,000 meters in 1 kilometer. So the kilometers will cancel out there. And there are 3,600 seconds in an hour. And we're going to want to divide here 30 by 3,600 seconds in an hour. Okay? So therefore the hours cancel out. And we'll be left with meters per second, seconds squared. Meters per second squared. So you do this calculation, 1.5 times 1,000 divided by 3,600, and you get the answer for the acceleration. And that answer is 0.417 meters per second squared. Okay? So if we look at these results here, we have a positive acceleration. However, the train was slowing down to a stop. So this is just another illustration that acceleration doesn't necessarily have to be positive or negative for your object to be speeding up or slowing down. Here's a situation where we have a positive acceleration, but the train is actually decelerating. Okay? So whenever we have a velocity that has an opposite sign of acceleration, that means whatever object we're talking about is slowing down. Okay? So we had a negative velocity. If we had a negative acceleration, that would mean the train would be speeding up. But a negative velocity and a positive acceleration means the train's actually slowing down.